Question 7 in chapter 11 is asking, two people carry a heavy electric motor by placing it on a light board 2 meters long. One person lifts at one end with a force of 400 newtons and the other lifts the opposite end with a force of 600 newtons. A, what is the weight of the motor and where along the board is its center of gravity located? And B, suppose the board is not light but weighs 200 newtons with its center of gravity at its center and the two people each exert the same forces on as before. What is the weight of the motor in this case and where is the center of gravity located? So let me grab my whiteboard. Part A. Here are the parameters provided for part A. So R of the board is 2 meters. And then F1 equals 400 newtons and F2 equals 600 newtons. So 400 plus 600 equals 1,000 newtons. Since the system is in equilibrium, that'll equal 0. The weight of the motor is equal to the sum of the forces given by the two persons, which is 1,000. So R1 is the distance from F1 to the motor, and then R2 is the distance from F2 to the motor. So R1 crossed with F1 will equal R2 crossed with F2. Since the system is at equilibrium, the torque on the left must equal the torque on the right. So I have R1 equals 2 minus R2, which will equal 2 minus R2 times 400, which will equal R2 times 600. So 800 minus 400 R2 will equal 600 R2. 800 equals 1,000 R2. So that gives that R2 equals 1.2 meters. Sorry, R2 equals 0.8. And R1 equals 1.2. And that was for part A. So R1 plus R2 equals 2. So I just substituted 2 minus R2 in for R1. Then I solved for R2 to find 0.8. So part B, let me erase this. That was part A. Part B, since the board weighs 200 newtons, the motor must only weigh 800 newtons. Because 1,000 newtons minus 200 newtons equals 800 newtons. So equally subtract the 200 newtons from both forces results in 300 newtons and 500 newtons. Then I'm just going to repeat the substitution and solving for R2 as I did before, the same process, and I get R2 equals 0.75 and R1 equals 1.25. And that was part B.